Okay, so we're still dealing with differential equations with linear differential equations. Okay, linear differential equations. Okay, so where were we? Okay, we're just about to start first order linear differential equations. So first order means the highest derivative is the first derivative, and the first derivative is there, and that's the highest. Okay, so first order linear differential equation then is just the last two terms: a1 times dy dx plus a0 times y equals f of x. Okay, now you can divide through by a1, and then you rewrite this thing as dy dx plus p of x y equals q of x. And this can be solved by multiplying through by an appropriate integrating factor. For these problems, the appropriate integrating factor is e to the integral in terms of s of ps, this is the p, and the integral from, well, anywhere to x. The anywhere is where the constant comes in. You know, because this is a first order, so there's going to be one constant of integration when you solve it. You're going to get one unknown, which can be specified by one boundary condition or initial condition, one condition of the form like y of 0 equals 1 or something like that. So e to the integral of ps in terms of s from anywhere until x. Okay. The reason you do this is because when you multiply through by that, you get this. Okay. So multiplying that by e to the blah, 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 plus now p of x times y e to the blah, blah, blah. And on the right-hand side, you have q of x times e to the blah, blah, blah. Now this thing is actually the result. You can think of this thing as a result of applying the product rule to this. Okay? So effectively what you're doing here is you're taking this side of it, you're looking at this side, and you're saying, oh, there's a dy dx and here in this term plus something and a y. Well, that is a little bit like the result of applying the product rule for derivatives to something. You get one term with a dy dx, other term with just a y, then stuff. But that stuff here isn't right, so you multiply it by something to make it right. You get and what you do is, there's a p of x down here. You want, when you differentiate whatever's in front of here, you want to get a p of x down. So of course, that's going to be e to the something like p of x, because that's going to bring the p of x down when you differentiate it. Okay. So then you multiply this, you get this, and that's resulted in the product rule to this. Okay, so you can rewrite this whole thing as the derivative in terms of x of this product, a product of that and that. And the right-hand side is still the same. Okay, now you just integrate both sides. You have derivative of this is equal to this, so the integral of this, which is just this thing inside here, is equal to the integral of this. So you need to integrate this. So you integrate both sides, and then you rearrange to find the y, to find what y is in terms of x. Okay. So we now have an example. So this was the general method. Now here's an example. Solve y dash minus 4 of xy equals x to the 5 e to the x, subject to y of 1 equals 0. So this is already in this form. So this is first order, but it's already in the form which we want to get it to apply this integrating factor stuff, where the leading coefficient is just 1. Okay? The coefficient of the derivative is just 1. This is already in that form. We have 1 times y dash there. Okay? So first of all, we calculate the integrating factor. So remember, the integrating factor will be what? It'll be e to the integral of, now what's the p? The p is the 4 over, so it's 4 over, it's minus 4 over x, so we change the x to an s, minus 4 over s, and ds, and integral until x. Okay? So we need to calculate this now. So they do it in two parts. First of all, they calculate this integral. Okay? It's minus 4 ln absolute value of x. So you can bring the minus 4 in here. But now x to the an even power is already positive. So you don't need, you can drop the absolute value sign and just have ln of 1 over x to the minus 4. And then you take e to this whole thing, so e to that, and you kind of, so it's e to the ln of 1 over x to the minus 4, but that's just 1 over x to the minus 1 over x to the minus 1 over x to the minus 4. I'm not sure why you changed it to 1 over x to the 4. E to the ln, that should be just 1 over x to the minus 4, right? Which of course equals x to the 4, surely. So the integrating factor is x to the 4. What's happened here? The integral of this is minus 4 ln x. You bring in the minus 4 there. So you have ln of 1 over x to the minus 4. Okay, which is of course the same as ln of x to the 4. Okay. Then you look at e to the that thing, so e to the ln x to the 4, which is just x to the 4. So now you multiply through by the integrating factor, which, why do they get 1 over x to the 4? So then they do use 1 over x to the 4 as the integrating factor here. You get this. That's just the derivative of this. But why is it? Where's this extra minus? Where's this 1 overness coming from? That's x to the 4, ln x to the 4, so that should be x to the 4, not 1 over x to the 4. Just the integral to x from 0 to x. So the x is that term is positive. Ln of x to the 4. Well, so they multiply by 1 of x to the 4 for some reason. Both sides. They had x to the 5 on the right-hand side. So now they have just x, and they have 1 of x to the 4, and they have 4 of x to the 5 now, because there's an x there. Then you have the derivative of, this is the same as having derivative of y of x to the 4, because this term becomes y dash times that, and then the y stays there, but you now take the derivative of this, you get minus 4, and then the 4 changes to a 5, with a minus 4 changes to a minus 5. Sure, that's fine. So if y of x to the 4 equals, now you integrate both sides. Integral of x e to the x is, okay, you do that by parts, you get this. Now you multiply through by x to the 4. So now you get x to the 5, e to the x, minus 4, and that. But, hey, why was integrating factor 1 over x to the 4 and not x to the 4? So the integrating factor is meant to be e to the integral of ps ds. Okay, ps comes from this p of x. So in this case, So in this case, our p of s, in this case, our p of x was minus 4 over x. Okay, so that's the same. Okay, minus 4 over x. So our p of s here is integral of p of s. It's minus 4 over s ds. So you integrate that, you get what? You get minus 4 ln absolute value of s, but it's evaluated from some constant, unimportant constants to x. That's 2x, so you need to sub the x in. So you have minus 4 ln absolute value of x. And you can bring the minus 4 in here, and you have x to the minus 4, absolute value of x minus x, absolute value of x to the minus 4. Ah, here's a mistake. It's not 1 over x to the 4, that should be a plus. 1 over x to the 4. Sorry. It's just 1 over x to the 4, or x to the minus 4. Okay, sorry. Ln of x to the minus 4. Okay, because when you bring this becomes ln of absolute value of x to the minus 4, but that's the same as ln of 1 over x to the 4. But when you raise something to the 4, it takes away the negative anyway, so you don't need the absolute value anymore. So you have 1 over x to the 4, and that's the same as 1 over x to the 4 is the same as x to the minus 4. Okay, fine. So the integrating factor it really is what they said. They made a small sign error. Okay. So then you multiply through by the integrating factor. Yes, you get this. Okay. At any rate, you could check to see if this is the solution, right? So the solution can be split into two pieces. The solution to the associated homogeneous equation, that's this bit, and a particular solution. So you can tell this is the homogeneous bit because it's multiplied by a constant, right? Because of course the homogeneous thing will have a solution multiplied by a constant. Why? Because it's going to be, the homogeneous equation is going to be, this was the equation, the homogeneous equation will be first order, so it'll have just one constant in it. It'll be one-dimensional. That's the homogeneous equation. And then this part is a particular solution. Okay, so we can check that those really are solutions. So we are saying that the homogeneous solution is x to the 4, or constant times that. So if that's y naught, then y naught dash is 4x to the 3. So that y naught dash minus 4 over x times y naught is 4x to the 3 minus 4 over x times x to the 4, which of course does equal 0. Now the particular solution was, the particular part was x to the 5 e to the x minus x to the 4 e to the x. So the derivative of that is now 5x to the 4 e to the x plus x to the 5 e to the x minus 4x cubed e to the x minus x to the 4 e to the x. Okay, so that all comes to x to the 5 e to the x. Then then the terms with 4 plus 4. There's two of them. 5x to the 4 minus x to the 4. 4x to the 4 e to the x minus 4x cubed e to the x. Okay, so then that means that yp minus 4 over x, yp dash minus 4 over x times yp, because the differential equation is y dash minus 4 over x, y times y equals the right-hand side, will be yp dash then is x to the 5 e to the x plus 4x to the 4 e to the x minus 4x cubed e to the x. We have minus 4x times whatever, well, that's not yp there, that should be y naught, the homogeneous equation, the homogeneous solution. So, sorry, no, that's yp, this is the differential equation I'm solving. So times by x to the 5 e to the x plus 4x to the 4 e to the x minus, sorry, I want yp here, not yp dash. Yp was x to the 5 e to the x minus x to the 4 e to the x. Okay, of course. So this whole thing becomes x to the 5 e to the x plus 4x to the 4 e to the x minus 4x cubed e to the x minus, now we have 4x to the 4 e to the x, and then we have plus 4x cubed e to the x. Okay? So what does this come to? These two terms cancel out, these two terms cancel out, and we're just left with x to the 5 e to the x. Was that what we were meant to get on the right-hand side? Yes. Okay, so that really is a particular solution. So we've checked that our solution is correct. And then there is actually an initial condition given, y of 1 equals 0, and that will tell us what the constant is. So if y of 1 equals 0, we let in this equation now, let x equal 1 and y equals 0, you get what? You get 0 equals 1 to the 5 is 1 e to the 1 minus 1 to the 4, which is 1 e to the 1 plus c times 1. So that's 1 minus 1 plus c. So it's c, so c equals 0, as they say. So the final solution then to this equation with the initial condition y1 equals 0 is just the particular part. In this case, it's just y equals x to the 5e to x minus x to the 4e to the x. That'll solve this equation and satisfy this condition as well. Okay, and I'll leave it there.